First of all, I'm here on behalf of my colleague Paolo Bolletta that could not attend the meeting, so I'm presenting his work. This morning we talk about next generation access network, and we analyzed several FTTH architecture. But the question is how we can really exploit all layer 2 bandwidth available by adopting FTTH architecture now. So to answer this question, we set up an experimental testbed, and we analyzed the most popular operating systems TCP/IP stack implementations, and the result will be shown. The aim of this work is to investigate the impact of the consumer software or the customer software environment over QoS evaluation. And what we will show that operating systems, so Windows or Linux, can strongly limit the exploitation of the available bandwidth. So some quality of service measurements has been carried out according with the recommendation, ETSI recommendation number 202, that we consider to evaluate quality of service by means of FTP transfer protocol. This work is within the framework of the project that I previously presented. So the choice of TCP independent techniques, in our opinion, is closer as possible to end user effective experience on broadband access services. When we talk about internet access, we are not talking about real-time services. Parameters are the same I showed in the first presentation. And this slide is taken by StatCounter Global Stats and represent the most popular operating systems from July 2010 to July 2011. As you can see, Windows XP is the most popular operating system. This is important because I'll show you that it affects very much the bandwidth available at the end user by means of a TCP mechanism I'll show you. And another thing that I have to point out is this Mac and Linux implement the same kernel Unix, so we can assimilate the TCP behavior. Okay, this is the three TCP stacks, which are the differences. The first one has a fixed maximum received windows. And as you know, the throughput is defined as the minimum between the received windows, the congestion windows, divide the round trip time. So if this value is fixed as an upper bound, consequently the throughput will be degraded. Okay, Windows 7 Linux does not have the same problem. Anyway, congestion control would affect the measure. To create an end-to-end setup, we have to choose the right file size, and to completely exploit all the congestion avoidance mechanism, we have to choose a file that is very long. So we take in consideration 10 times the headline speed as a file size. So if you have a 6 megabit per second connection, you will download, for example, a 70 megabit file. This is the testbed design, and what we arrange to have this measure. The important aspect is given by the delay generator that allows us to emulate different dimension of network involved. And we directly connected a GPON to our edge router. The quality of service within The network is guaranteed by means of an MPLS future. In particular, we set up an LSP with 1 gigabit per second guaranteed bandwidth. So the real bottleneck is the client, the same client on which 3 different operating systems runs. This is the first results. As you can see, in this region, and this one, that represent the mean RTT value in Italy, you cannot employ the bandwidth. So if you have these operating systems and you pay for a 20 megabit per second bandwidth, you really exploit half the value you are paying to. In this slide, we show the FUB ratio defined as the output, so the real bit we really employ, the payload of the TCP packet, on the line throughput. And also in this case, you can see that using Windows XP, you cannot exploit the bandwidth available. And in this case, we are considering on the GPON, gigabit passive optical network. I can assure that it is the same if instead of a gigabit passive optical network, you choose a point-to-point architecture. It's the same because we are focusing on bandwidth. But the important results is that also with other operating systems, the congestion control affects the measure very much. So nowadays, it is impossible to exploit 100 megabit per second, even if I don't know what we can do with 100 megabit per second, but this is another question. So in conclusion, we demonstrate that that depends about the quality of service on by operating systems, a reduction of throughput up to 50% or 90% for 100 megabit per second profile has been demonstrated, and we say that the testing scenario for FTTX, or in general, for example, fiber to the home access, needs to be described not only according to physical parameters, but also pay attention to operating system implementation. So, in my opinion, the hardware, the CPE hardware, is the real bottleneck of the end user measurements. If you have any question, I'm happy to answer to you.